Welcome everyone to this new Matrikon webinar where you are going to learn how to enable all your CODESYS and no CODESYS product with OPC UA. Hi, my name is Eliana Fernandez and I will be your host for today's session. Before we start, I would like to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets that you can use. Please click on any particular widget icon to open it. The presentation will be followed by a small survey and a Q&A session. If you have any questions on today's topic for the speakers, please use the Q&A widget and submit your question. We will try to answer to all questions at the end of the webinar, but if we run out of time, it will be answered later via email. We do capture all questions. Also, you can expand your slide presentation area by clicking on the maximize icon on the top right of the slide area, or by dragging the bottom right corner of the slide area. If you have any technical difficulty, please click on the Help widget. It is the question mark icon in your console and covers all the common technical issues. We are recording this session and we will be sending the link to all the attendees 1 week after the webinar. Also, an on-demand version will be available 1 day after the end of the webcast. To access, you can use the same audience link that was sent to you earlier. At this point, I'm delighted to introduce our speakers. Darek Kominek, our Global Marketing Manager for the Matrikon business, who will be in the company of Dimitri Philippe, CEO and founder of BE.services, member of Matrikon Eco Partner Program for the FLEX SDK development. You can check our presenters' information in the bio window at the left of your screen. I will now pass control over Darek to start the presentation. So thank you all for your attention.
Thanks, Eliana. Hello, everybody. So in today's presentation, we'll go over a few topics. Number one, we'll go through a quick introduction. Glad to have Dimitri Philippe with us from BE.services, as Eliana mentioned. So we'll give you a quick overview of what Matrikon or BE.services do, what we're known for. And then we will run through a little bit of the data connectivity context. So there's a lot that's happening in the industry. Give you a recap of some of the highlights, especially when we're dealing with OPC UA. And then we'll get into some questions and a deeper perspective into what's happening in the embedded side of the world, something that Dimitri can provide in spades since that's what his company works with all the time. As well, we will have a demonstration for you on how an OPC UA system embedded into a CODESYS environment works as well. That'll be run by Dimitri, and then we can take some of the questions. So the first order of, it'd be great to get to know you guys as well. So maybe if you could just answer, a quick question as far as, what your focus is. We know that this topic is interesting to a lot of people. So whether you're an automation vendor, PLC manufacturer, or maybe a machine builder, etc., just let us know. We'll tally up the results afterwards, and we can make those available to you as well if you're interested. All right, so thanks for answering that. Now let's get started. First of all, what does Matrikon do? Matrikon has been around for roughly 20 years. We have started off as a service firm working basically with oil field and industrial applications, doing the communications for those. Of course, over the years it evolved, specialized on OPC and then OPC UA. So currently we actually service, worldwide, basically every industrial vertical. So whether we're talking about discrete manufacturing or process, we do it all. And in the end, because connectivity is ubiquitous, it's needed throughout the industry. And even though some of the specialized functionality changes, in the end, you're dealing with the same concepts, just in different industries with maybe different sensitivities. Certain industries are more regulated, others are more time sensitive, but in the end, the communications are the same. So Matrikon has a lot of experience working basically around the world with all the different industries. So what Matrikon provides, again, a very quick overview. The key one, of course, being that we're talking about embedding OPC UA. So right out of the gate, Matrikon provides a OPC UA SDK. It's called the Matrikon FLEX SDK. And that's basically what serves as a foundation for our other products, which we build on top of it. Matrikon both services the development community, so vendors basically looking to implement OPC UA, as well as the actual applications built on top that are aimed at the end users, whether that's IT and OT personnel, engineers, system integrators, and such, moving upwards. So anytime you're trying to move data throughout your enterprise, whether it's network traversal or setting up redundancy and such, that whole host of products come together in our portfolio. So data technology is what we call the overall offering, and the goal of that is to fill that gap that sits between the IT and the OT side of things. I know there's a lot of spillover between even those two definitions of IT and OT. In the end, you're still using networks and applications that run between them or on them. But really the focus of DT technology or data technology is facilitating the ability to work with the data that's being generated by the sources. So all the functionality that's needed to actually enable data movement and the ability to use the data, that's what DT, data technology, stands for. So our applications are built specifically for that purpose. Now,
Hi everybody. So in a few words, BE.services is a software company, so we're an engineering service company providing anything from consulting to implementation of different software technologies, mainly to automation vendors. Our background is very strong in industrial automation, and we help vendors in the design of their new control systems, mainly new products, and we help them pick the right technologies and implement these technologies. There are 4 core competencies in the company. The first one would be Linux. So Linux has established itself very, very widely now in industrial automation, and we have very strong experience. We do a lot of Linux implementations for our customers, and this our offering goes from consulting around the distribution to use all the way to implementation and optimization. We do Qt implementation of Qt applications. We do optimization of the performance. We work with OSADL, integrate or their real-time preempt patch, and we even provide consulting around open source license compliance, which is very important and too often, unfortunately, forgotten or ignored by companies, and this is quite important. So here we cover really everything from consulting, implementation, and even further into open source license compliance consulting. Besides Linux, we have a lot of experience, and this is the background really of many of us in the company. CODESYS, so we do implementation of the runtime system on any platform. We do extensions, we do integration with third-party software tools. We even, in some cases, when it makes sense, we are able to make editors for the CODESYS IDE, so not just at the embedded level, but also in the development software, so we can do customer-specific extensions. So here we have really key expertise in the company. We also work in cybersecurity, so this is becoming more and more important in our industry, mainly through the need for digitalization. So security is a new topic for industrial control systems, or maybe IoT devices, mainly at the edge. So security is not to ignore, and we're happy with had this relationship with Kaspersky, the absolute expert in cybersecurity, and also providing now products for embedded systems like their Kaspersky operating system, a secure operating system, and their security kernel KSS that also runs under the other operating systems like Linux. So here we do anything from distribution, consulting, and implementation work. And of course, OPC UA, this is a very, very important part of our business right now. So for OPC UA, we work very closely with Matrikon as a consultant, integrator, and distributor of the SDK. So it's obviously technology that is booming, I would say, right now. Everybody has a request for OPC UA, and we provide worldwide consulting and training, integration of the stack, support and extensions of the stack, porting under other operating systems, and also maintenance, and then even application development. So this is a real key competence in-house.
Having covered the introductions now, what we'll do is jump into sort of an overview as far as the role that OPC UA has been playing and continues to play in the market. So let's take a look at some of the data connectivity evolution, I guess you could call it. So overall, when we look at the changes that have come in with the advent of the industrial Internet of Things, or in Europe as popularly, focused on the discrete side, the Industry 4.0 movement, is just the necessity for starting to not only being able to see deeper into the shop floor, but also to make better sense of that data, to increase the value of that data through context, and as well to ensure that information is safely made accessible and transferred across the networks. Now, each of those points sounds like an individual item, and they are, but they actually, each one forms a necessary part of the overall foundation. Given the dependence that we're asking businesses to start to have on the data to basically run in a truly digitalized format, you have to ensure that the number one, you can rely on the data so that it's secure. So that is an essential aspect. A lot of homework was done by the various governments, actually, in the case of Germany, for example, to ensure that if there is a standard that's chosen to sort of act as the backbone for Industry 4.0, that it has sufficient security and other capabilities like robust modeling, and obviously act as an open standard and such. So all that has to come together in order to truly implement the vision of what Industry 4.0 or Industrial Internet of Things can actually be. Right? So here I've listed a few of the key sort of highlights that are required of a proper data foundation for the applications that get built on top of it, the real shiny things that show up in the news and people talk about artificial intelligence and machine learning and using humongous amounts of data in the cloud to do analytics, and which then help you to either diagnose systems better for better maintenance, which then prevents, of course, unscheduled downtimes, or to actually improve the process itself, to optimize fleets and compare them, and therefore also have dashboarding, which is really important on the decision-making side in the business to actually, compete as a business. It's not just about technically how you run your process, it's actually how that ability to produce whatever you're making, how efficiently and cost-effectively you can do it to compete with the rest of the globalized market. So going up the stack, so simplifying infrastructure, number one, is super important. The more components you have in your overall stack of applications and enablers, let's say, for communications with the equipment, the higher the chance something can go wrong. There's more technical debt from that because you have to, of course, have people who know how to support that and work with it and maintain it. There's also a need to be able to traverse networks. Of course, when security sets in, we all hear about the IT-OT gap. So when you're dealing with a standard for communications in the modern era, it doesn't just have to ensure that it transfers the information correctly or that it's even open so that others can connect to it. You also have to have the security aspects built into it, and the ability to work with existing IT infrastructure, because that's what IT does. They primarily focus on the security of the system, aside from, of course, keeping it running. So standardized information modeling is also key. If different vendors' equipment is supposed to work together, especially in given industries or across industries, as we're starting to see, sort of the mix in between different verticals. What's really important is for each consumer of the information to be able to understand what type of model is being used to represent the context of the data that's coming from different data sources. So that's a key aspect of modern data connectivity. And then, of course, standards-based, so you don't want proprietary communications protocols, and as I mentioned, security. So that kind of works up the stack. Now, this is not much of a spoiler alert, but basically all of these aspects of what's needed in a modern data connectivity standard actually come nicely together, packaged into something called OPC UA. So from the OPC Foundation, OPC UA is a standard that really has matured from years of experience working with a simpler, sort of the previous version, the Classic. We call it OPC Classic. And now OPC UA is sort of its, grand entry into the mature standard that actually handles, everything that we just talked about in one package. It makes it quite a complex package or standard to implement. There's a lot in there, but the reward of taking care of all that is that you get exactly what you need as a foundation for the connectivity. Having said that, and seeing how OPC UA is, playing a major role in a lot of the markets, basically all the industrial verticals, something that'd be interesting also to take a look at, given how many people we have in the presentation here, is just what your journey is when you're going through this. How many, how far along are you in deciding to start using OPC UA and inside your products or not? Okay, so moving forward, one thing that is worth looking at is what the big picture is overall when we talk about all this connectivity. So it doesn't just end with data being shared between systems on the shop floor, kind of a horizontal communication. When we're talking about OPC UA or just modern data connectivity, it really does have to be facilitated throughout an entire enterprise. And therefore, if we were to take a look at sort of how the technology stack and the capability stack, what we're dealing with primarily here, we're talking about embedding things directly into the data sources, so whether it's the PLCs or machines or other types of devices. What sits on top of that is the ability to add the context. Of course, it'd be great if that context comes naturally built into the device itself, but if it doesn't have it, then of course it's something that needs to get added. Then there's also the question of reliability, so things like redundancy, security, as I mentioned, and again, being able to traverse the network. Because what happens is you don't necessarily want people higher in the enterprise to connect right down to your sensor. It may not be able to handle that many connections if there are multiple connections required for it. So instead, you kind of work bottom up where you're feeding information into the enterprise. There might be various gateways that collect this information, or enablers at least, and applications that allow you to talk across firewalls and et cetera. So the communications needs its own infrastructure specifically for the data movement to get it to all the places that are required in the enterprise. So in Matrikon, we happen to call that our flagship product, the Matrikon FLEX Dispatch. It is sort of the key implementation for data technology, which does basically all these things, whether you're concentrating information together like a gateway, so you're federating sources or moving through the network and et cetera. But for the purposes of this presentation, what we're going to look at is basically down at this level when, even though you will it's good to keep in mind the whole picture of what, where the data goes. It has to start at the data source, which is the embedded environment, right? So what we'll do now in this presentation or going forward is we'll focus specifically on the embedded context. Now, having said, there's a lot that happens throughout the enterprise. So one of the interesting questions is, what attracts you the most or your customers to OPC UA? Is it all the above? Is there something specific? Very interesting, very telling to see, depending on which industries people come from and what scope they work at within the enterprise, which of these sometimes pops up. But we'd appreciate your input on this. And again, we'd be happy to share these results with you afterwards. So what we'll do now is we'll shift a little bit to start to talk about some of the... So now we'll move into more of a question-answer period, seeing how we have Dimitri with us, and they do so much of the development and working directly with especially machine builders being based out of Germany, where the majority of Europe's machine builders come from anyways. Let's go through some of the questions. So Dimitri, what does the data connectivity situation look like in the automation vendor and the machine builder space, from your perspective?
Mm-hmm. Okay, so to answer this, I guess we need to look back a few years. OPC UA has been there and specified, and there are different SDKs available for a long time already. But I would say back 3 years ago, there was a big movement towards towards subset and TSM. This is where I think this factory automation market really started to pay more attention to OPC UA. And the last 3 years, I would say that the end users, so what I call the end users, the machine builders, they started to use OPC UA that they receive from their automation vendors, their suppliers. And basically, mostly, for most of them, it allows them to, let's say, to replace what they did with the standard OPC in the past, so the COM-DCOM OPC. So that means just data exchange from a device to an ERP system or other management. So this is what we've seen, let's say, 2 years ago, maybe even up to a year ago. It is started changing because the machine builders, since they have UA, they really started to look into what UA provides beyond just data connectivity. And they really started to see opportunities and benefits using this technology and asking their suppliers to support a lot more than just having access to data. So, and this is changing at the moment quite a lot because the vendors, the PLC manufacturers, are really required to look into the different SDKs that there are in the market because they now have real use cases. They need to solve problems. They need to solve. They need to answer requests, and they realize that not all OPC UA solutions can cover everything. So this is really what we see happening. So we basically we see right now that OPC UA is being used in a much wider scope than it used to be a couple of years ago.
Right. Okay. Yeah, that makes sense. That's actually what we sort of see across the board, even let's say outside of the embedded space. Just the sort of draw in towards OPC UA, especially as a lot of the information modeling efforts and all that start to pick up as well. So maybe then moving a little closer to home, as far as challenges that you're seeing that vendors specifically, those who are using CODESYS, and I mean that's a dominant system. So what do you see them facing? What does their situation look like?
Yeah. So that's very interesting. First of all, not everybody may know, but CODESYS is a very popular technology that is used by hundreds of automation vendors, so manufacturers any kind of control system. So it is a very, very well spread technology that, of course, is at the end used in devices by hundreds of thousands of machine builders and users in general. So and depending on the vendor and the product line of the vendor, they have issues now when they look into making a decision for the right solution, the right SDK to use, because they have a series of products. So they don't have just one product, but they have a series. So they have from a small, maybe intelligent I/O or small device with some control functionality, all the way to multi-core based PC, industrial PCs, having small PCs. They have embedded systems with different processors, different operating systems. They have drives on which they also want to have OPC UA connectivity. So they have really a lot of different devices with different CPUs, operating systems, some of them without operating systems, some of them with very little memory. So it's important for them to have a solution that basically works for them for all the different products. And it's not easy to find a tool that does it all. Also, they have need for a client. Some of them have displays, HMI, SCADA system, and they want client solutions. So they have products that have that are CODESYS programmable, some that are not CODESYS programmable. So they need a standalone OPC UA solution as well. And for them, it's very difficult to go with 2-3 different providers of UA SDKs, because you have to keep up with all the licensing, the maintenance. Some tools support specific functionality, some others cannot. So this is basically the challenges that the vendors have right now to, one, find a tool that covers all the requests in terms of platforms, and two, have a tool that is flexible enough for them to answer the new requests, or not just flexible, but complete enough to answer all the requests that their customers have. So this is basically the main challenge at the moment.
Right. Okay. Well, then I think, yeah, that I guess the next step that everybody will have then as an anticipation is, well, okay, so there are these challenges that vendors face. So what's the solution?
So BE.services, you saw that earlier, but we are both a partner of you guys with Matrikon, and we're also a premium system partner for 3S. So we work a lot of technology. And in order to facilitate the access to a complete stack that would be available for them on non-CODESYS-based devices, but also on CODESYS-based devices available for small platforms, for large platforms, a stack that provides very important features, all the security features, support complex data types, historical alarm and conditions, events, and even more now the support for companion specs, which is becoming a very, very important requirement now in the market. There are so many, I think about 50 companion specs are available or in the making. So the vendors need to be able to use a very complete SDK like Matrikon FLEX OPC UA SDK, and implement that on their non-CODESYS-based devices, but also on their CODESYS-based devices. And in order to facilitate the implementation for the vendor, so that not every single vendor needs to do this implementation on their own, so we decided to make such an implementation, so not only to facilitate the work, but also to speed up the time to market. So for those of you listening that are not that familiar with CODESYS, so this is, I'm just going to give you a quick overview. So CODESYS always has two main parts. One part is the IDE, that is the IC 1131 programming environment, so that is a free software that is installed on a laptop, and that allows the user to program a complete automation application. And when I say complete automation application, I mean it's not just PLC programming, but it's also motion control, it's robotics, It allows the user to configure its I/Os, its field buses, because it supports a lot of different field buses. Actually, all the most important field buses provide editor for visualizations as well. So you can do HMIs from CODESYS. So basically, this is a tool that machine builders can use just one tool and basically design and program a complete machine. So the second part that is necessary, of course, to run on this application, it's necessary to have a CODESYS control runtime system that is implemented on the target hardware, so typically on the PLC. So and this implementation is done by the vendor. So they just have a commercial technical relationship with 3S. They buy the runtime system, they install and form the runtime system either on their own or in that case, we help a lot of them also to do that work. It runs on many different operating systems. It runs on bare metal platforms as well. And once the runtime system is ported, then it's available to cover whatever functionality has been chosen. So, and in order to use the Matrikon FLEX stack as a server together with CODESYS, so we have ported the Flex stack into CODESYS. So we have basically done this integration with a piece of code that is an I/O driver, so a runtime system component that does the interfacing between the CODESYS runtime system and the Flex. So there is access from the runtime to the stack and to the functionality of the stack. So that is one piece. But then, in order to use for the automation engineer, as I mentioned, he's used to do the complete programming configuration of the machine in the same environment in one project. So in order to keep the same strategy or the same culture, then we also developed a new editor that is completely integrated in CODESYS that allows the engineer to configure the server, the Flex server, and also to do the data setup, and also to configure the data that he wants to expose over OPC UA. So this implementation is done in a way that the porting and the integration of both technologies is already done. So it's a very easy access to use both technologies together.
Great. Okay. Well, thanks for the overview of that. I mean, it's a comprehensive system, and I think the part that I really like in that is that not only do you make it possible for and you support people using the Flex SDK to implement OPC UA server, but the fact that they have that accelerator code, which basically lets them stay in the context of what CODESYS does or how it operates, and to basically just stay in the flow of that development, yet get access to all the functionality. I think that's quite a useful, accelerator to get people into the market. So, it's again very interesting. There are vendors, of course, as you mentioned, who may have various implementations of different products. So not all of them might be running on CODESYS. So definitely would be great to hear from our audience just how much or not you are in that camp, whether it's just running purely on CODESYS, that's all your products run on, or you have kind of a mix and such. Again, I would appreciate everybody's input on that. So now that we've gone through the sort of the background as far as what OPC UA has brought in to the table when we're talking about the IIoT, some of the functionalities that are used, and also what that experience is for people in the embedded space. And now what we have is a demonstration. So Dimitri, if you want to get your gear set up there, we can now run through the demonstration of basically the OPC UA server based on Flex running inside CODESYS as an overview. So go ahead.
So before we actually go into the software demo, I want to make sure that you understand which setup we have here. We have the main part, a Toradex based PLC that is based on an ARM Cortex and a Linux operating system on which we have implemented the CODESYS control runtime system and the Matrikon FLEX OPC UA server. Then we're going to access that PLC from a laptop with the CODESYS IDE. And we will access the PLC also from an OPC UA client that will be the Matrikon OPC UA Explorer. So keep this setup in mind so you understand what I do. So I'm going to switch to CODESYS. So for those of you that are familiar with CODESYS, you will recognize the environment with the tree. I have here the communication settings through the CODESYS gateway, accessing the PLC or the control system, which is based on the Apalis IMX8, as I was mentioning. And what is new in this tree, this is this component here, that's the Matrikon FLEX OPC UA server. So this is a new editor completely built in CODESYS and available for free on the CODESYS store that allows you to configure the server and to configure the data that will be exposed over OPC UA. So what do we have in this editor? We have the generic configuration, generic setup of the server. We have the setup of the data that we want to expose. We have status information, and we have information about the editor itself with the manufacturer of the version that you have in this case. So what can we do in the setup of the server? So we have the host name, so we tell where the server is and we get the name from the device. Then we need to tell which interface we're going to use for the OPC UA communication. So I can browse all the interfaces available in that device, and I pick the Ethernet interface. I have only one on that device, so that's where we want to communicate with the UA client. I can set the port number. Then I've got my endpoint information, so I'm gonna copy this because I'm gonna need to add it in the client later on. After that, we have the possibility to define the number of sessions that we want to allow from the server. So will we have just one session to one client, or will we possibly have more than one sessions? In this case, we can limit at this level. Then I have the scan rate. So how often will I update the value from the server point of view? So we have here in this case 10 milliseconds. We're gonna do a second for the scan rate. The security policies. So security is a very important part of OPC UA technology. So in here we support the different security that are available from the specifications. In order to simplify this demonstration, I'm going to take none in that case. Then we have the authentication. So here we can do with a certificate, username, password, or anonymous. We're going to check with username and password. So I'm just going to add here the new username and password that I need to keep in mind because I'm going to need that later on when I want to connect to the server. So a very important feature that is already implemented in that CODESYS editor and this implementation of the Matrikon FLEX into CODESYS is reverse connect. So not all of you may be familiar with reverse connect. This is a very important feature that is specified by the OPC Foundation for UA. It is also called FireBridge within Matrikon. And basically what it does, and it is available from the Flex from scratch, but it's also implemented in CODESYS, so we can use it in combination with CODESYS already, is that the main issues that you have in the field to connect the client with the server is that you have typically a firewall with no open ports for you guys for security reasons, and it's very bothering to set up communication from the client to the server, and you would normally need to access a colleague from the IT department that allows you to have communication through the firewall. What Reverse Connect does is that it establishes communication, it initiates communication from the server to the client, going through the firewall and then allowing communication back and forth. So if you initiate the communication from the server to the client through the firewall, then the client can then access as a trusted channel the server. So, and here you can just set it up here by putting the address of the client that will be accessing the server. So in that demo, we will not go into details how to set this up, but we have separate videos either from Matrikon or from BE.services that present you the functionality in using the Flex on different channels. So after the server is set up, then we're going to do the data setup. So I have here a button that allows me to upload all the variables from the application, and then I get my different variables that I have in my small application here. That is just a demo, but that's for the principle. It's very easy to understand. And then I can select what I want to do with these variables. So these variables, for example, I want to access via data access. So that means getting the current values. We have already prepared the historical access, events, and alarm and conditions in CODESYS. It's not available in this version in that editor, but of course this is supported by the stack. So the stack already provides all this functionality. The stack is very complete and provides any functionality, any facets from the UA specs. But not everything is ready in this first version for the CODESYS editor. But we've prepared it already, so this can be updated, and this is already planned in our roadmap for further versions. So then I have the possibility to select the access rights, read-only, write-only, or read and write. Then the type, this is uploaded from my application. And then what is very nice is that we have the possibility to enhance a variable. So if we have a point that we want to expose over OPC UA, it's not just a value. We have a complete information model that we can provide along this value. And what we have prepared is, for example, the unit. So the foundation specifies a bunch of different units that we can use for a value. So for example, here, let's say we want to do liter per second, and we can add liter per second. In this value, we can add engineering units range, minimum and maximum. So we can say, okay, this is the range we want to stay in, and it shouldn't go further than that. Then we have instrument range, minimum and maximum, that may not be the same range. And we have also a sampling rate per variable. So here, if you remember, I have a second for the server scan rate, but I can decide that, for example, this one would be only enough to do it per every 10 seconds. This one can remove every second, or one can remain every second. So I have the possibility also here to decide the scan rate per point. Okay, so once I've done this this setup in the server, I can download my application to the PLC, and I can start the PLC. So now the application is running, and we want now to access these variables from a client. So, and if you remember the initial slide, so as a client we use the Matrikon OPC UA Explorer. This is also a freeware. This is a very, very user-friendly tool. So, and I want to add a server. And do you remember I copied the URL of the server? So this is where I need to add it. And then I can search my server, and I found it. This is the Matrikon OPC UA. I had no security policy. I have none. So I have my session, and if I want to connect right now using Anonymous, you see here that I get no connection. I get a message that I have a bad identity because I had put a username and a password. So I need to put username and password. And now I can connect to my server. So I get in the object the list, the 4 variables that I wanted to expose. So I can now bring them in the data view window. And then I have them displayed. So what I want to show you also is that the enhancement that we had. So if we go to a specific variable, I have the possibility to do settings. So here I have 10,000 milliseconds, so 10 seconds, because this is what I had set up. And for this one I have 1,000. So this is already taken over. If I want to reduce, and let's say, okay, I want just every second for this one, you will see that this will not be accepted, because even though my server scan rate is 1 second, this specific variable can only be updated every 10,000 seconds. So I have no possibility to do it. So that's a very good way of enriching the data directly, very easily from the CODESYS environment, and seeing this in the client. So what else did I have? I had also here different engineering units. Remember, I set up a liter per second. So this is sent with the value. This is sent to the client. So here, if I go into the attributes, so I have now the liter per second that I can see it, and then by setting up my client, then I have the possibility to display, of course, this value to make sure I have a better understanding of what this this value is. It's not just a number, but it is a number plus a lot of information behind it. So I guess this is it for this short demo. Hopefully you understand the principle, you understand the integration that is done in CODESYS. So there is no need to have a different tool to set up your server. This can be done completely within CODESYS. And as a reminder, the Flex is extremely complete. Contains all the facets. It can be used as a client and as a server. It can be used with or without CODESYS. It can be used in different profiles on very small footprint systems, or in a complete profile with all functionality on a larger hardware platform. So you have a complete freedom on how you want to use OPC UA. And then we are available if you have any questions. Should it be now, or should it be per email or per phone call?
Thank you, Dimitri, for such amazing demonstration. So now, next step, go to the resource list that you have next to your audience control and download the Matrikon CODESYS editor, so you can go directly and download it from there. Now we will pass through the Q&A session. So Dimitri, Darek, whenever you are ready.
Okay, great. Well, thanks, Eliana. So now we'll go to the more exciting part of the presentation. We'll do some questions. So let's see. Actually, we have a question here from Nolan, who's a FAE at CTSS Industry Teach Gateways. Question is, you can see 50,000 different sensors and actuators into any OPC UA client while still letting the PLCs simultaneously and independently access and do control. Sounds like a statement, but perhaps there's some insight there. Dimitri, do you want to comment on, I guess, that statement?
Yeah, sure. So I would say it very much depends on two things. One would be the power of the CPU that is used on the PLC, And the second thing would be also the scan rate for these 50,000 tags. I mean, if those need to be provided over OPC UA, exposed over OPC UA, like every millisecond, of course, that will require a lot of resources from the PLC. So I guess it's necessary to do tests. It does definitely depend on the CPU that is on the device, but we have experience with that number of tags on not so strong CPU on a power PC actually in process automation application, oil and gas, and the performance is quite okay, especially if we talk about CODESYS, but other systems have the same possibility to of course to do priorities of tasks, so you can set a higher priority for the control task and a lower priority for the OPC UA communication.
Okay, thanks. So another question, actually follow-up question from Nolan. Nolan, thanks for being so active. What might be a popular deployment strategy using OPC UA that you would recommend for an end user whose business starts in 10 states and provinces, can be converted at a low level into an OPC UA server and desires to end in AWS, so Amazon Web Services, in the cloud, for example, where the internal devs will write various apps that use the company-wide data from all the field sites. So that, there's a number of things to touch on there. Number one is just, I guess, first you have to deploy, or you have to get products that are actually OPC UA enabled. So one thing I'd say is that, outside of actually embedded development, which, mostly this crowd would look at, which is making sure that the systems that are deployed to field are OPC UA enabled, so that they can either publish data out if you're doing pub sub, or to be able to do things like reverse connect to talk directly to cloud, or work through the network. So aside from actually implementation of how you develop the equipment, as an end user, the options typically are you have to find some mechanism to be able to convert information into OPC UA. So in your we say brownfield, but basically existing infrastructure that's let's say OPC UA based, you need to convert that into OPC UA and then move that data through typically your organization. It's setup of the network, which in industrials is typically the Purdue model, right? The level 1, 2, 3, 4, etc. So, I mean, in that case, the Matrikon dispatch that was briefly mentioned, I talked about it at the start. That's what that's used for, to actually do the traversals across firewalls, domains, etc., and at the same time to handle large volumes of data. So as you start off with small sensors or just small amounts of data from each individual unit, like these examples are mentioning here, tens of thousands of sensors and such, that's a data stream very quickly becomes a data torrent. So as that starts to come together, applications like the data technology we talked about, dispatch, will let you bring that information together and send it up. And then it's bidirectional. One of the strengths of OPC UA is actually that it's built in that if you're doing the client server side of things, you can actually do bidirectional communication. So you can actually also talk down to these systems. So number one, you have to OPC UA enable the things. Number two, you have to use, once they are OPC UA enabled, you have to navigate typically through the corporate network. If the companies that you're dealing with are willing to allow things to go directly from shop floor or wherever they're, or field to cloud, then of course that skips certain challenges, but then introduces others. And yeah, once you get it into the cloud, then it's more of a question of just how are you capturing that data, or how are you ingesting into cloud, and then from there you use it how you will. So yeah, actually we work with AWS as well at Matrikon, both Microsoft, so the Azure side and AWS. So we have experience on that as well, if you guys are interested in that. Okay, another question. This one, how about Matrikon support with Allen Bradley, PLC, and Rockwell RS Linux runtime? So this looks, I mean, the way the question is phrased sounds like it's more towards just, how you establish connectivity as an end user. That's more towards the connectivity products that Matrikon has, whether it's, the ability to actually connect and convert that data from that environment into OPC UA. So things like, our actually connectivity drivers, or UA tunneler, which does the conversions between Classic and OPC UA. That's what that would sit at. In general, though, seeing how we're in this webcast focusing a bit more on the development side, PLC vendors who have, various types of RTOSs, real-time operating systems, or other environments on their devices, whether they run CODESYS or not, regardless of what you're running on board, as long as you've got the compute power to actually do this, to run OPC UA, the Flex toolkit will support any real-time operating system. So yeah, if you're talking about the implementation side of things, where you want to natively run OPC UA on board, it would be suitable for that environment, regardless of what type of runtime or RTOS you're using on board. Okay. All right. Okay. Does anybody have any other questions? All right. Well, then, if that's it for the questions, guys, thank you very much for joining us. We would love to get your feedback on, how you found this this webcast. As Eliana mentioned, we've got a few things available both through this interface here and as we showed in the presentation. If you are using CODESYS, I encourage you to check out the editor plugin, so that you can see sort of how that would work. On that side, if you're doing any type of implementation then of OPC UA, then check out our website. And actually, if you're looking to talk about your projects, or you're just getting started or in the middle of them, encourage you to talk to Dimitri and his team at BE.services. So with that, we will end this presentation. And oh, actually, one more question popped in here. And NIST recommends to increase the key size for security policy like basic 256 to higher value. How to handle such recommendations while using OPC UA for products which undergo long validation phases? Yeah, so good question. One thing with OPC UA is that it does, over time, it will evolve. It has to, because things are changing all the time, especially in the security front. I mean, right now in OPC UA, we've introduced the elliptical curve algorithms, which require less compute power and improve the strength, let's say, of the security without draining the resources more. So those types of things will continue to happen. Now, they're typically non-breaking. Vendors will have to decide how to navigate that. All security is a form of probabilities and risks, right? And then the severities of them, that's how you prioritize them. So depending on what the applications are, if you have a system, I'm assuming the question here is towards, how you update things in the field. So OPC UA will facilitate it. It's, let's say, non-breaking. It doesn't cause whatever is implemented on board a system, an embedded system, to not work. It's just that it may not be recommended if it's exposed to an environment where the risks are greater. So how vendors implement that on board, whether you can update the firmware so that it, for example, will update the algorithms or not, of what's available on board, that's really a product-by-product decision. So as long as you're still using the same things that were certified previously, the same algorithms, then they'll continue to work. But if the need exceeds the pain of having to recertify, then basically the vendor would have to start to do it. There's really no way around it if you're working in environments where any change to any of the software or algorithms used requires the recertification. So unfortunately, that's just the reality of changing times with security. So what OPC UA does is it tries to avoid, of course, making changes that are breaking backwards. So as new standards come out, we might say that things are deprecated, but they're not like removed and they quote unquote won't work. So it would just be a decision of how, you know, when I guess you jump into that fray. About the, if you have some further questions on that, definitely happy to maybe answer them more specifically. We definitely, as you guys may know, we're connected with Honeywell as well. We have a lot of access to the cybersecurity teams as well. So if there are additional questions about security and sort of the procedural stuff, we could answer that as well. But all right, that's all we have right now in the inbox here. So again, thanks guys, and we look forward to seeing you in our future webcasts.